Hello.
Awesome. Great.
Co-chair of the division.
Yes. Okay, we can get started. Hi, everyone. I am Ella, and I'm the programs director at the American Solar Energy Society. I would like to thank you all for joining us for our grid modernization and storage webinar. This is all about the importance of microgrids and the role of battery storage. Before I start out, I just want to give you a brief chat around the American Solar Energy Society. We are a 501c3 nonprofit organization that was established in 1954. We advocate for sustainable living and 100% renewable energy by sharing information, events, resources to cultivate community and power progress. You all are welcome to join our community at any time at aces.org/join. You can see the little arrow up here. I've become a member. All webinar registrants get a 10% discount of our membership, so feel free to use code webinar for any of our ACES memberships. We are doing a lot of things this year. We're really excited. We will be having our Solar 2026 conference on October 19th through 21st in Austin, Texas, in collaboration with one of our state chapters, the Texas Solar Energy Society. They are celebrating their 50th anniversary, so we're really excited to be joining them and collaborating with them for Solar 2026. For those of you that are interested in submitting an extended abstract for the potential to present either an oral or a poster presentation, please feel free to submit that at aces.org/conference by this upcoming Monday, February 2nd. We're really excited about that. We'll be hosting a women's PV workshop this upcoming June in Boulder, Colorado. More information can be found on this link, aces.org/women's PV workshop. June 19th through 22, that's a Thursday through Monday. We'll be installing solar and designing, sizing, and installing a PV system at a local high school. You are all welcome to join us on our National Solar Tour, which will be taking place on October 2nd through the 4th this year. It'll feature a collection of local tours and tour sites with solar and sustainable technologies all across the US. Signups are open to host a tour of your own, whether that's in person or virtual. You're welcome to sign up or take a look at a tour near you at nationalsolartour.org or aces.org/tour. And lastly, we have our quarterly Solar Today magazine. We're always interested in having folks contribute to the magazine. So if you're interested, please feel free to send an email to editor@ases.org and send a 2-paragraph pitch of the article that you would like to write about and include your bio and some writing samples. Do want to make a note that this webinar is recorded. We'll be putting this up on our YouTube shortly. And without further ado, I will hand it over to our Grid Modernization and Storage Chair, Bill Guernsey. Thank you so much, everyone, for joining.
Again, thank you all for being here. So why does a solar energy society care about electrical power storage using batteries? So renewables, mostly solar and wind, are actually dominating new installations of electrical power generation worldwide. Depending whose numbers you believe, that can be around 90% of new power storage is renewable. Why is that? Well, really importantly, the economics actually support that now. Uh, Also, for a lot of good reasons, there are clean energy goals that areas have. And then finally, for the reliability of the grid, renewables can be very helpful. Every one of those could have its own webinar, but you know, good background. And we're not talking about we already have a substantial amount of power coming from these sources. Just some examples, just some tidbits here. Texas, January to September of last year, about a third of the power um, was generated. I got a typo in there. Forget about 24. About a third of the power was generated by renewables for that 9-month period. And compared with 2024, that was about a 50% increase. So like I said, all this new generation being put online, that's renewables. California, January through July of last year, solar by itself, 39% of the utility shipped electrical power. So there's a lot of renewable energy generated power already on the grid, and then all this new installation, renewables. Um, so finally, and these renewable sources are intermittent, right? We all know solar and wind are intermittent. It's not 24 hours a day. Um, that's a departure from having far fewer plants, big plants, centralized. They run around the clock. You run your grid off of that. Well, now we have all this intermittent power already and a lot more coming. So the grid is evolving for that. And that includes a massive amount of storage, taking this power that's generated, when the sun is shining or the wind is blowing, and saving it and using it other times. Batteries are crucial for that. So go ahead and flip to the. So today we're going to talk about battery electrical storage. In this case, how it's applied mostly in the commercial and industrial scale, but it's all part of the same interconnected grid. And this is going to be presented by Isaiah Wier-March from Kronus Engineering in our very own Boulder, Colorado.
All
All
right.
right.
Well, thank you so much, Isaiah. Yeah, you're welcome to share your screen. And as I mentioned in the chat, if anyone has any questions, please put them in the chat and we'll get to them towards the end of his presentation.
Yeah, so thanks, Ella, and thanks, Bill, for the nice introduction there. And yeah, my name is Isaiah Wier-March. I am a mechanical engineering by education and ESS or BESS engineer by trade, I guess you could say. Um, uh, I work for Kronus Engineering, which is a battery integration firm, mostly specializing in designing and building kind of like turnkey battery energy storage systems, like Bill mentioned, tailored to commercial and industrial needs most of the time. Um, and what we do is we build in the wheelhouse of 70 to 5 plus 70 kilowatt hours to 5 plus megawatt hour systems that can be stacked out. And basically, kind of like what Bill was saying earlier, my topic is going to cover the importance of microgrids and how energy infrastructure is changing and growing. More often not than these microgrids include renewable resources like wind and solar. I think it's really important to learn more about the advantages of these microgrids. And especially in my field, the role of the batteries can be an extremely valuable factor in the microgrid itself. So solar, renewables, and wind really go hand in hand when they come to the microgrid. So yeah, they can drastically improve performance. So I'll just jump right into it. And I think if you have any burning questions, drop them in the chat. But otherwise, I think we'll save those and have a little discussion at the end for anyone who has a question. So yeah. So my first slide is going to talk a little bit about microgrids in general, how the world is changing and adapting. Bill got into this a little bit, but depending on what data you're looking at, you are starting to see a big change in how microgrids are growing and being established in the United States and around the world. Specifically in the United States, if you look at this chart, you can see this is showing the distributed or microgrid versus centralized generation, and new growth. So basically, since 2001, we've been exceeding the centralized generation expansion in the distributed energy resource world or microgrid world, and it's only projected to grow and basically begin to double and double that rate of centralized power. Things go the same way as they've been going. Um, this is important because we see that I think it's like 70% of global infrastructure right now is over 25 years old. Um, and as battery and solar technologies are seeing huge reductions in costs, we're just seeing microgrids, renewables grow to a pretty high point. So, yeah, and it's not just for the cost. I mean, while the cost is decreasing a lot, there are also many advantages to implementing DERs, microgrids over large centralized systems. Um, and basically, you see it promoting grid resiliency, and reduces the demand of the large central plants. When you have something like a natural disaster or a cyber tax, basically putting all your eggs in one basket can be dangerous, and distributing those to smaller points can add redundancy and can improve a lot of that stability. Another way you get some advantage out of the microgrid is you get to regain some of your grid sovereignty. Um, Basically, less reliance on large energy companies, and those centralized stations can um, basically reduce the demand and lower energy costs. So there's less price gouging, getting all your energy from one source. And this is where we see a lot of our customers coming to, Kronus, looking for basically peak shaving, and demand management is a huge advantage. So you have a way to stabilize and smooth out. So when you do have wind, solar production, you can store and use it during peak loads, or after the sun goes down, or when the wind stops, essentially. So adding a BESS into a microgrid only increases your reliability, your ability to hold critical loads. Now I'll talk a little bit more about the peak shaving thing in the next slide. So basically the role of the battery in the microgrid, like I was saying, adding a lot of redundancy and grid support through frequency regulation is huge, but we really see people adapting to the renewables and microgrids, like it or not, for monetary reasons. And demand charges can be a huge reason for that. Basically, throughout your day, you're looking at intermittency from wind and solar. And what you can do is store your energy while prices are low or while the sun is good, and then during high peak hours, you use your battery to push more energy, and you kind of stabilize your loads and allow for smoother transition of energy. So we see demand charges account for significant portions of energy bills, and sometimes up to 50% or more. So reducing these charges can improve profitability and sustainability, especially for energy intensive businesses like EV charging stations, manufacturing facilities, commercial buildings. The BESS can provide pretty measurable benefits in reducing those costs. I think according to NREL, a stat from NREL, it was 30 to 70% of energy bills come from demand charges during peak hours. Um, and that's what including a BESS into your microgrid or your DER can help reduce. So there are some challenges with implementing microgrids and renewable penetration. Like I said, the intermittency of sun and wind can be a huge problem. You can only provide energy, when it's sunny or when it's windy. Um, Adding a battery can be huge for that because you essentially spread out your ability for usable power. Um, there's also low inertia. A centralized system carries actual inertia, and when you move to an inverter based um, generation, you lose kind of that lack of spinning mass. But um, let's see. I can talk about this graph that I have here a little bit. This is basically one day of information, which is an active system we have here that's solar tied. So you have this yellow line here is your solar production over the day. And this is a BESS tied system. So what you're looking at here is your solar peaking and kind of going out throughout the day. And this is your battery charging kind of during those availability hours of solar. And as you progress throughout the day, you have this chunk of time at the end when solar essentially reaches zero. We're still able to output in this system 2 megawatts of power for an hour and a half, or the capacity of the system. And this specifically increases energy production by 37% daily. So adding batteries into the microgrids and the renewable energy is just essentially pays for itself when you're outputting energy. So I can talk a little bit more about a couple case studies that we have. This first one is in relation to EV charging. So it kind of just drives home some of the importance of adding batteries into little microgrids. With the introduction of more and more solar cars, the demand for fast charging is huge. In order to do that, you need a lot of power very quickly, and your standard centralized grid isn't able to keep up with those power demands. So by adding a battery, you can essentially charge during off-peak hours, load up your bank. Ideally, you're connected to some solar. This specific project was not connected to solar to start. So you're just relying on charging at lower cost times. And then you have a balance of when people come and charge their cars, the battery is actually able to support the high power demands and offset high grid usage. So not only are they able to add level 1 and level 2 chargers, they're also able to use the cost system to their benefit and implement fast chargers. So that's exactly what happened. A level 2 and 2 level 3 chargers were added. And in this case, they were able to receive a grant to expand in the area. So whether that means adding something like solar or wind or more EV chargers is just going to keep growing. So the next case study that I've got for you guys is a hospital in Massachusetts. So similar to the EV charging, this hospital uses a lot of energy, and every year they have hundreds of $1,000s of energy bills, and high demand and peak usage. So what we did is we analyzed their weather and solar data, and along with their usage data for the last year, and designed basically an appropriate solar and battery power field for them. In this case, it was a megawatt of solar and 2 megawatt hours of battery. Um, and you offset peak power, and completely cover the energy of the hospital, you know, with your solar, and then your banked energy in the battery throughout the evening and into the night. So this is saving this building probably hundreds of $1,000s a year just by implementing solar and battery, um, and also meeting, decarbonization goals. So, yeah, essentially you have huge benefits, both monetary and environmental, from adding microgrids, and adding a battery itself can drive home those advantages even more by banking and mitigating high demand and peak costs. So kind of a short demonstration there for you, but that's what I got, and I'd like to open it up to any questions, and we could have a little discussion.
Thank you so much, Isaiah.
Yeah.
There's some comments in the chat. I can read them briefly, and if you have any additional comments. But Drew said anyone with battery has a nanogrid. And Emily said depends on how the system is designed. Some systems, particularly at household scale, are not designed to operate islanded. And if there is a battery, they will shut down if grid power is lost to avoid unexpected backfeeding. Do you have
Yeah.
any additional comments on that?
Yeah, just kind of like what Emily said. I mean, there's a lot of growth in the nanogrid world as well, and people implementing battery systems and solar on their houses. Like she said, essentially what you don't want is to, excuse me, if there is a power outage and your battery turns on, you don't want to backfeed the grid, because you can have interference, non-synchronization when the grid comes back, and you can put basically workers that come to service those grid lines can be put at risk. So you need to have a proper shut off system that keeps your island from interacting with the grid itself.
Awesome. Thank you so much. Emily also said, I'm not entirely sure what W/R/T is.
With respect to
Oh, okay. Oh, thank you. Should know that. With respect to demand charge reduction in selecting the battery sizes and power, for example, kilowatts, what was the intended battery lifetime frame, and to what degree did any expected aging due to that power use affect sizing in kilowatt hours?
Yeah, that's a good question. And the world is changing a lot. So we generally use lithium ion type batteries. And the state of health is pretty good. We see our projects with good state of health for, decades. And it does slowly degrade over time, but we do our own analysis, and we talk with the customer generally and look at, what the battery manufacturer gives us for lifetimes and degradation, and we pair that with their application. So it's definitely something that you want to look at. And there are certainly chemistry based decisions that you can make. Like an LTO battery, for example, will have probably currently the best lifespans as far as keeping internal or lifetimes. You can see LTO batteries maintain a good state of health for probably past our lifetimes. So those end up costing a little bit more, and customers don't generally go for those, but we do them every now and then just because they're so reliable, and they have such great lifetimes.
Awesome. Thanks so much. Oleg asks, what's the best software for sizing a BESS for a facility?
Well, I mean, this is kind of like uh, I wouldn't say there's like dedicated, there might be some dedicated softwares for it out and about, but that's kind of what our company does. We look at specifically sizing for every different um, site specifically. So, with the hospital that I was talking about, we looked at their historical usage data over the course of a few years, looked at how many, kilowatts, megawatt hours or of energy they're using every month, every year. And then we can take weather data and look at irradiance, historical irradiance data, and use those information bases to size specifically solar and batteries. So we don't necessarily just plug into a specific software, but we look at the affecting variables and make a decision based off that.
Great. Wow, we got a lot of great comments coming in and questions. Robert asks, what battery bank voltages are you running at max?
What was that one?
What battery bank voltages are you running at? And then
Okay.
maybe on average, and then what is the max?
Yeah, so this also depends project to project. Our systems are in like the under 2000 volts range, and it really is driven by the inverters that we use. Um, Inverters all have a different range of minimum and maximum voltages, so we balance our battery voltage range to what inverter we're using most of the time. But I would say on average, um, we do megawatt hour solutions that can stack out in parallel, but each battery itself is within the 1,000 to 1,500 volt range.
Great. Next, James Ornstein says, do you have any comments on the issue of distribution grid upgrade costs for equipment and control systems to accommodate increased bidirectional power flow and the associated issue of cost shifting between residential rates and C&I that can use batteries to reduce demand charges?
Yeah, let me read that one again.
It's a long one. It's like 4 up.
Yeah, okay, I see it now. Distribution grid upgrade costs for equipment. So I guess what you're asking here is kind of like the price analysis between the cost for increasing the um, cost for equipment and control system to accommodate the back and forth power flow with respect to residential rates and commercial rates. Yeah, I mean, we take everything's kind of case by case, but um, there certainly are costs to preparing to be able to use a battery or a microgrid to demand manage, but um, there really are a lot of cost savings for, it depends what you're doing if you're selling back to the grid and what your local grid charges or accepts for energy. But and it's such a wildly changing environment. You see costs always changing for buying and selling energy. But currently, it's been definitely advantageous to go to a microgrid with renewables and battery and manage and avoid those peak charges and even sell back to the grid itself. Did that answer the question?
James, you can unmute yourself if you wanted to. You haven't.
Yeah, the issue isn't the benefits to the commercial and industrial customer. The issue is the distribution utilities are complaining about the cost to accommodate that and the fact that it allows the C&I customers to reduce their costs because it reduces their demand charges, but that means that somebody else has to pick up the slack, and that falls on residential customers unless there's some change in rate structure. So it gets to be a regulatory issue.
I see. Yeah, it's interesting and how those costs pan out in the world of um, energy suppliers does get pretty complicated. I wouldn't say I'm very involved in that side of it, so I'm not sure I have anything very interesting to say about that. But I mean, that is an interesting problem, and hopefully we can change the way that structure is made to relieve some of the residential charging.
It looks like Emily also commented on that as well. She said, if this kind of stuff about rate design interests you as it does me, you might want to check out Lawrence Berkeley National Lab's Energy Markets and Policy newsletter. They have some interesting commentary in a recent presentation/report about the increasing trend towards prioritizing demand charges over energy charges.
Thanks, Emily.
Awesome. Some other questions. Oleg asks, have you specified any BABA complaint BESSs? If so, how many BESS manufacturers are there?
Yeah, so we are currently working on a few BABA or BABA compliant BESSs. And basically what that means is built in America by America. And what that means is you need to have a certain percentage of your system built or made in the United States. And you see that being beneficial to the world of, funding. So that is something that we work on a lot. Are you asking about the battery specific manufacturers or the BESS in itself? Because essentially there are no US based battery companies that really hold their own to the current battery world. So our BABA compliant BESSs are using batteries made in China, but using, I think it's 70% of other components and also work done in the United States to meet the BABA requirements.
Awesome. I think kind of along similar lines, maybe Dustin asks, which specific battery manufacturers do you use?
Mm-hmm. We've worked with a bunch and we still do. I mean, we've done Toshiba LTO projects, and we've done, we use Core Power lithium and Pylon Tech lithium quite a bit. We've also done some projects with a company based in Washington called Zinc 5, and they have a nickel zinc chemistry that's really interesting. Very good for high power output, but not as good for capacity, but it's been utilized in a number of just like heavy hitting short UPS or commercial applications that require high amounts of power fast. But I would say the Pylon Tech and the Core are our go-to battery systems for like a NMC type battery chemistry.
Awesome. Thank you. The first question Stephen has is, data from several national labs show that most battery capacity is used for grid support because it is far more lucrative than backup or peak shaving. Do you have any comments?
Yeah, I mean, there's certainly advantages to grid support. We see that a lot. I think the peak shaving thing is huge and growing, and people are starting to implement that a lot too. But that all kind of depends on how the energy provider is going to buy back energy, which is a very changing environment. So we'll see how things continue, but they'll always be used for grid support, which is very valuable.
Awesome. Second question from Stephen is, one of the main values of a microgrid is providing resilience. It can greatly help cost benefit analysis to convince customers by valuing resilience in the face of power outages. How have you valued resilience, or Kronus?
Yeah, so huge. I mean, basically the purpose of the battery, right? The original purpose is, or one of the great purposes is to have resilience, instantaneous power. So a lot of our projects need backup power or available energy immediately. So it's certainly a huge part of the storage world.
Awesome. Thank you. Mark asks, what lithium ferrous phosphate, LFP, being used for these applications? Or what are?
Yeah. Or is it why?
What?
What
It's
what
what
are
or why? It says, I think, what are lithium? Yeah, what are LFPs being used for in these applications?
yeah, so large scale storage. So we'll see LFPs used for essentially we've had some projects in Alaska which replace generators. Essentially, people have been in these remote villages. They use generators to power their entire little town, which gets pretty expensive. Being getting diesel out to those little villages like $50 a gallon. So we can do is get a battery out there, pair it with solar or wind. Solar is only good in the summer, but an LFP is certainly applicable for a project like that, where we're just providing power for whatever the application might be.
Sorry, he updated the question. It says, why are LFPs not being used for these applications?
Well, I mean, they, I think, I mean, we've used them in the past, so I think they've still been applicable in these projects.
Thank you. Trudy asked, given that federal ITC are still available for industrial projects, where is the area with the highest growth potential for BESS projects?
Um, I guess any solar or wind paired system that is looking to sell back or replace general grid tied applications to renewables is where we see that change happening a lot.
Great. Mark, or no, Emily, she asks, in your Alaskan projects, you haven't had issues with batteries struggling to maintain charge in deep cold situations. Were those Li ion chemistries or something else?
Yeah, lithium ion chemistries. And essentially what you have to do is you have to have redundant HVAC in order to keep up with the cold. So we do insulated storage containers, and then, like I said, redundancy in HVAC to keep the system warm in the winter and cool enough in the summer. It's kind of interesting because you need you need to keep the batteries cold, and then you need to have enough HVAC power to keep them thoroughly cold. And then usually in like an application like that, it's heating, so you end up having to do both extremes of the hot and cold. But it comes down to just using proper HVACs.
Drew asks, how can we convince utilities to actually pay for grid support for aggregated res? I think is that residential? Aggregated. It's the last, second to last in the chat.
Sure. Well, I'm not sure, to be honest. I mean, like I said earlier, I'm a little bit out of the loop on the on the grid side aspect of the power suppliers, so in the legislation. So hopefully they can help push the direction in that way, so we can kind of continue to grow. I think it's beneficial to everyone to have those distributed utilities, but obviously no one wants to pay for it. So I guess something we'll have to keep an eye on.
Awesome, thank you. Mark asks, what is the difference in performance between lithium ion and LFP batteries? Is this issue manufacturers not making large LFP? Is this issue manufacturers are not making large LFP batteries?
I would have to do a little bit more research on the difference. I'm not generally in as much of the chemistry side, so I can't answer this question super well. But yeah, like I said, there's the chemistries are always changing a lot as well. So it's just something that we keep an eye on and use just the best ones that we can.
It's just some comments in the chat, not necessarily questions. Drew said, if grid support is highest value and res can supply it, why not more progress? Wilden said, ratepayer money should not be used for utilities for lobbying, etc. Connecticut passed this bill. And Drew asks, is there any progress on V2G, which is cheapest source of battery?
Yeah, I'll have to look into that a little bit. I'm not aware.
Awesome. Any additional questions, comments, thoughts, feedback? People are also welcome to unmute themselves if they'd like and ask. Oh, I see a question. Trudy said, are municipal utilities more supportive of BESS projects than distribution rural electric co-ops? Maybe this is not in your area of expertise, question mark.
Yeah, it's hard to say. Not something I dive into completely, but yeah, something to look into. Sorry, I don't have an answer for that one.
Oh, good. Just some more comments coming in. James shared an LBNL document, PDF. And Drew said the overhead of, I don't know what this word is, Ngring. Commercial scale is high, Mayfield engineering helps, but still a problem. I don't know what that means. All right.
What I meant was that there's a lot of engineering overhead and utility overhead and commercial building managers overhead involved in doing commercial scale microgrids. Mayfield Engineering offers some seminars and whatnot on that, and it helps, but it's still a big problem compared to, say, the engineering overhead involved in a residential scale battery, which is near zero. You put it in, plug it in, and the installer sometimes knows enough which buttons to push to coordinate it with the grid. So I'm curious whether there's been any progress made on simplifying the C&I engineering and its costs.
Yeah, it probably gets easier and easier. We do a lot of work with the local jurisdiction. There's basically that's probably the hardest part of implementing anything like that is meeting the local jurisdiction standards, and something like UL 9540 is sometimes required, which can be costly. But as people are more aware of these types of things, and as it's done more, costs go down, and I think we're moving in the right direction. But it's so much. I mean, the scales are so different from commercial and resident, depending on the project, but can be so much higher, which just demands a lot more support and equipment.
Great. Also, Emily had, with respect to Drew's comment, V2G is still an open technical question. Many vehicles are still not designed for it, and it may require some infrastructure changes to the house. Not all householders want or are able to make those changes, and not all contractors are qualified or confident in making such changes.
At this early stage, it seems that those issues should not be a problem. The other problem is there's so much vaporware out there of these things. You know, if you own an F-150, you're supposed to be able, with their particular system, to be able to do V2G. And there are examples out there of it happening. What I'm having trouble with is people don't seem to be moving forward very quickly on any of this. And it's got to happen, and got to happen soon if we're actually going to get the benefits that are available with micro and nano grids onto the grid. We have to get paid for it, and it have to be a non-vaporware product. And we got to get going on this, guys.
Thank you, Drew. All right. We technically have about 12 minutes left of the webinar. We can definitely end early, but want to make sure everyone got all their answers and questions asked. Any additional thoughts?
Is there anything that he'd like to tell us that's coming down the pike that we should be looking for and that we can help make happen?
Yeah, I mean, just continuing adding more and more microgrids to our grid. So I don't have anything specifically in like a technological advance point of view, and I'm not super up on the new chemistries, but yeah, we're going to keep doing our thing and adding, as much renewables as we can, and pairing it with batteries to increase the effectiveness of those systems. So yeah, just keep an eye out for more and more solar and battery.
Awesome. I think one last question from Dave. Can you comment on the Spanish blackout?
I cannot comment on that, actually. Sorry, I'm not aware. I don't have enough information.
Well, if he's referring to my attempts to speak Spanish with people, we don't talk about that.
And one other thing, Carly, CJ's note taker, Otter Eye, seems to still be on. I thought we got rid of those things.
I'll remove that. Thank you.
Thank you.
Great. Well, thank you so much, Isaiah. That was such a thought-provoking presentation, and thank you so much for answering all these questions. Really appreciate everyone's time today. Thank you to Bill and Emily Moog for being our grid modernization and storage division leaders. I'll send a follow-up with the recording and some other additional things on how to get involved with ACES. And yeah, thank you so much again. I hope you all have a wonderful rest of your day.
Yeah, thanks everyone. I appreciate it. Thanks for listening.
Thank you.
Thank you.
Bye.
Bye.
Bye.